Hey folks, next up is we're taking a look at law of cosines. Remember, law of cosines is used, if our given information is three sides, so we're given the length of three sides of an oblique triangle, the side-side-side case, or if we're given the length of two sides and the included angle, the side-angle-side case. And here's basically, this is it. This is your law of cosines in all of its glory. In triangle ABC with sides A, B, and C, A squared equals B squared plus C squared minus 2BC cosine A. B squared equals A squared plus C squared minus 2AC cosine B. And C squared equals A squared plus B squared minus 2AB cosine C. That's it. You've got to know the law of cosines, just like you have to know the law of sines. Then I would write out over here some guidelines that I always share with people on using the law of cosines. So this is when you're given information, is side-side-side or side-angle-side case, and you're going to be using the law of cosines. If you're given the measurement of all three sides, so you're in the side-side-side case, my guidelines are find the largest angle of the triangle, find the largest angle first using the law of cosines. Now once you know the largest angle, it doesn't matter. You have two more angles left to find. Find either of the remaining two angles using the law of sines. The law of sines is a little easier case. It's an easier formula to use. And then of course you'd get the third angle by adding the two together and subtracting from 180. If you're given the side-angle-side case, I suggest, this isn't a suggestion, this is really the way to do it, find the missing side first using the law of cosines. Now once you know the missing side, once you find that using the law of cosines, you should then find the smaller of the two remaining angles using the law of sines. My guidelines, I'm giving you these guidelines for a reason. Notice in both parts here, side-side-side or side-angle-side, after we first use the law of cosines, we end up using the law of sines. And in both of these cases, when you're using the law of sines, you'd be finding an angle, you'd have to worry about the ambiguous case of the law of sines. My guidelines that I'm giving you here will completely eliminate any possibility of you inadvertently going into the ambiguous case of the law of sines. So I would say these guidelines, it's going to make your life easy. So know them. So what I thought we'd do is we'd do a couple of examples of using the law of cosines. All right, hey, here in the first example, we're going to solve the triangle given the length of side A is 55, side B is 25, and side C is 72. So I've gone ahead and sketched my generic looking oblique triangle and I put in the given information. And over here let me put the, I don't know, remember I've been calling this the solution area. We know A is 55, B is 25, and C is 72. So as always, we know 3 bits of information. We need to find the other 3 bits of information. And here we have to find the measurement of all 3 angles. So since this is the side-side-side case, my guidelines for using on how to attack this problem, my guidelines are to start off using the law of cosines to find the measurement of the largest angle. Remember, largest angle will be opposite the longest side. The longest side is side C, so the angle opposite it is angle C. So that's where I begin. I'm going to find angle C. And then I have to look at the 3 different versions of the law of cosines. Which of those versions am I going to use? Well, I'm going to use the version that involves cosine of C. So that means I'm going to be using the C squared equals an A squared plus a B squared minus 2AB cosine of C. Now let's just substitute in what we know. So C is 72, A is 55, B is 25, Oh boy, now we have to solve this equation. So let's see, solving this equation. I'd probably start off by doing 72 squared. And I have 72 squared is 5,184. And then 55 squared plus 25 squared, I have that as being 3,650. And then 2 times 55 times 25, I have that as being 2,750. And I have my cosine C. So keep in mind, and continuing to solve here, I'm trying to find angle C. I would subtract 3650 from both sides of the equation. And then I would divide both sides of the equation by negative 2750. So when I subtract both sides of the equation, when I subtract 3650 from both sides, I'd get a 1534 over here. And then I said I'd divide by negative 2,750. So I have 1534 over negative 2,750. That's cosine of C. So now I need to find angle C. Angle finder. Going to use inverse cosine. Angle C. C equals the inverse cosine of this mess. And when I use my calculator, I get angle C to be about, see, inverse cosine of that, I get C to be about 123.9 degrees. So I'll put 123.9 degrees. Now, according to my guidelines, it doesn't matter which angle we find next. It doesn't matter if we find angle A next or angle B next. And I'm going to use the law of sines. So let's find, following the alphabet, let's just go ahead and find angle A next. And notice how the law of sines kind of makes it a friendlier problem. I have the sine of A over 55 equals the sine of, we just found angle C, 123.9 degrees over 72. And then I multiply both sides by 55. And then I'm going to have I'm going to use inverse sine. And I should end up getting angle A to be pretty close to 39.3 degrees. So angle A is 39.3 degrees. So what's left? Angle B. Angle B, just simply take A plus C and subtract that from 180. And that would give an angle B measurement of 16.8 degrees. So that's a quick example of using the law of cosines to solve a side-side-side case. Next example, we'll look at the side angle side. Alright, hey, next example, we're going to solve the triangle given angle B is 75.3 degrees, side A is 6.2, side C is 9.5. Here's my generic triangle. I'll put in the given information, and there's my solution area. Hey, notice, and I didn't point this out in the last example. I mean, this is a side angle side. The last example was a side-side-side. But really, I have no choice but to start the problem with the law of cosines. I couldn't even entertain starting the problem with the law of sines. Because remember, for the law of sines to work, in order to use the law of sines, you have to know an angle and the side opposite the angle. Well, notice I don't have that pairing of known information. So I have no choice here but to use the law of cosines. Now, in my guidelines, I said the first thing we were going to do when it's the side angle side case, and I kind of look at my solution area, and it should jump out. The first thing to do, the first thing to find, really the only thing we can find, is the missing side. And that fits my guidelines. Find the missing side first. We're going to find that missing side using the law of cosines. Since the missing side is side B, I want to use the version of the law of cosines that involves B in it, and solving for B, and knowing angle B. So that means I'm going to, let me come over here. Say first we're going to find side B. I'm going to use this version of the law of cosines. B squared equals an A squared plus a C squared minus 2AC cosine of B. Substitute in what we know. We know A is 6.2, so we have a 6.2 squared. C is 9.5, so 9.5 squared. Minus 2 times 6.2 times 9.5 times the cosine of 75.3 degrees. And oh boy, if I use my calculator, I do 6.2 squared plus 9.5 squared minus 2 times 6.2 times 9.5 times the cosine of 75.3 degrees, I get B squared to be 98.76, I'm sorry, 79731413. That's a lot of decimal places. Obviously I'm going to take the square root to get B. So I take the square root, B is going to be the square root of this number, and here I'm going to round this now. I'm going to round it to 9.9. Now we have two angles left to find. I'm going to use the law of sines. My guidelines say, next, find the smaller of the two remaining angles using the law of sines. You have angle A, angle C. Which one of those two angles is the smaller? It would be angle A, because side A is smaller than side C. So we're going to come over here, we're going to find angle A using the law of sines. So we have the sine of A over 6.2 equals the sine of B, 75.3 degrees, over B, which is 9.9. Multiply both sides by 6.2 and then use inverse sine, and you're going to get angle A, or you should get angle A to be pretty close to 37.3 degrees. So we'll put 37.3 in here, and then angle C is going to be the easy one. Add those two together, subtract from 180, and you should get angle C to be 67.4 degrees. Quick reasonability check. Largest angle, longest side. Smallest angle, smallest side. So at least my answers are reasonable. And that's a quick look at law of cosines. So at this point in time, you know the law of sines, law of cosines. That means you can solve any oblique triangle. SOHCAHTOA would allow you to solve any right triangle. So in theory, there isn't a triangle out there that you can't solve at this point in time. Right triangles, oblique triangles, you can solve them all. Hope this helps, and thanks for watching.